As you know by now, I'm a big fan of writing things out as I go. So let's take a look at this. We have 50-pound and 80-pound packages. And as we go through, we want to be mindful of what are our unknowns here. So they talk about they need to carry at least 20 packages. So this is a number of packages. And then we have the total weight cannot exceed 1,500 pounds. Now notice they want to know the maximum number of 80-pound packages. So that lets us know that the unknown is the number of 80-pound packages, and the other unknown is the number of 50-pound packages. So first off, because we know that they have to carry at least 20 packages, at least means 20, including 20, or more. So greater than or equal to 20. And let's use meaningful variables. So for the number of 50-pound packages, let's say F. For the number of 80-pound packages, let's say E. I always like to use meaningful variables. In total, we can have at least 20, or we must have at least 20. And then the second inequality is saying it can't exceed 1,500 pounds. So in other words, it has to be 1,500 pounds or less. And that weight occurs when you have a certain number of 50-pound packages, each of which weighs 50 pounds, and then a certain number of 80-pound packages, each of which weighs 80 pounds. So even though this is an inequality or system of inequalities, we can actually put this into Desmos, assuming that it's essentially the same idea. And let's actually use those inequality symbols as well. So we'll go to Desmos, and then obviously you'd have this on your scrap piece of paper instead of just kind of in the middle of the screen like I have it. But let's type this in. We're going to use X and Y instead because Desmos won't let you use like F and E. And then we'll do greater than or equal to, which you can go to the keyboard, choose the greater than or equal to symbol. We'll put 20, enter 50x plus 80y, and then is less than or equal to 1,500. So we're figuring out which number, more specifically, when we're talking about the maximum number of 80-pound packages, that's our E variable, which we put as y. So we're really looking for the y coordinate being either 15, 16, 17, or 18. And we're looking for the intersection. So let me come out here, and then we can see the intersection is this portion here. So let's look along and see on the y-axis, let's actually even go to this point of intersection right here, which the intersection is this 3.3 repeating and 16.6 repeating. So if we're looking for what y coordinate is in the shading of both, notice if you go higher than the 16.3 repeating, you'll be in just the red. However, if you go lower, you'll be in the shading of both. So what may be a little confusing, and it gave me pause as well, is we know for sure that the y coordinate can't be greater than 16.6 repeating, because then you will no longer be in the shading where both the red and the blue are. So we could definitely go in and eliminate anything that's greater than 16.6 repeating. In other words, we can eliminate both options C and D. Now, when trying to figure out between 15 and 16, the idea is we got to find the maximum number of 80-pound packages. So the biggest number where it's true. So even though we could go down here and find ordered pairs such that the y coordinate will be 16 or 15 down here, regardless what the x is, the maximum number is going to be that 16, since it's obviously bigger than 15 and still satisfies or lies in this shaded region, making the correct answer B.